I'm also going to resume recording right now. So yeah, if you have any questions, please ask away. I'm going to just see if anything showed up in the chat. Nothing has showed up in the chat yet. Let's just share my screen. Oh. All right. I'm not going to easily be able to see if you guys have any chat questions. So, and by the way, if I don't see your chat question, please just shout or just unmute yourself and ask away. Does anybody have anything right now? Oh, there we go. I like waiting for people. Some more enums. Okay, enumerated data types. Okay, let's do one of those. Okay, let's see what I could do for enumerated data types. And I always have to look it up each and every time, but thanks Rachel for that, and I'll have a look at this. So let's do a brand new class, new item. Call it a enum struct or something like that. And I'm going to make, let's see what other things I could do here. Let's do pointers. Okay, or pointing devices, not pointers per se. So we have things on our computers like trackballs, like mice, like touchpads, like pens, that sort of thing. They're all different, but they all sort of use a coordinate frame. They use a two-dimensional coordinate frame. So where your mouse is in this space, essentially. And so you move around your mouse and you can figure out the distance that your mouse has traveled, let's say. So I'm going to make two different things. I'm going to make a position struct, let's say. I could take in two positions, or I could call it a vector or vertex struct, depending on how I want to call it. Point struct. So let's call it the point struct. So struct point, and a point struct is two dimensions in space. So int x and y. Fine. I may also want this enumerated data type. So I always have to look it up each time. Type def enum, right? Type def enum. And I always have to look it. I look it up each and every time, so I can look up the actual solutions if we wanted to. Let's cut lowercase that thing. Device, okay, and I'm going to have mouse, trackpad, finger, pen. Okay. So let's just double check what my thing is actually. Enumerate pointing device. I don't need type def. There you go. Every time. Syntax always. So this should, so that's undefined. That should be a problem. But that should, I'll have to look into what my syntax is for this. I wasn't planning on doing enumerated data types. Oh, it's not equals. It's just should be this. And put those down. It might be semicolons at the end of each one of these, but I'm not sure. Let's have a look at how this works. So int main. All I want is some way, an enumerated data type, as in I give a number to this. So when I use the word mouse, it will be 0. So every time I see the word, I could type the word mouse and I will get the number 0. If I put down the word trackpad, I will get the number 1. It's the next number in the sequence. I could also explicitly put all those numbers in there if I wanted to. When we look at pre-compilation instructions, or I call them macros, we might do something like this. Define my mouse is equal to my mouse, and we'll say that's equal to, well, let's keep it consistent. Okay. There are a bunch of different ways. We could have made a variable, named my mouse, and given it the value 0. We could have made a bunch of defines everywhere. These are just everywhere you see the word my mouse, the compiler will at compile time, swap in the word my mouse with the number 0 everywhere. It doesn't even figure anything out. It just hot swaps it all for you before it actually does the compilation. Or there's this, the pointing device enumerated data type. So I'm going to have pointing device, PD for pointing device is equal to trackpad. And it might give me a little kind of curse or something like that with it. Nope, doesn't cause me any problems. Okay, here's how we could use a pointing device. So I'm going to make a function and it's going to, there we go. It's going to return a constant character pointer, get device name. So what I'm going to do is I'm going to take in a pointing device as a parameter. I am then going to use a switch statement because these enumerated data types are really good for switch statements. For each one of those switch statements, when I find the right switch statement, I'm going to return a character string. It's going to return the name of the track device. So if I keep around this number, I can just get the text for what it's representing. That's what I'm going to try and show you right now. So all this function here is going to do is it's going to return the text name for the track for the pointing device. That's all it's doing. Okay, so I can have a switch, and this is really the reason why we use enumerated data types. I know that if I pass in the pointing device, first of all, it is limited to these 4 things. If I give it any other number other than those 4 things, I can't even call this function. So if I just use numbers, what if you give me -1? What happens? Bad things happen, right? If you give me anything other than what could be considered a pointing device, one of these enumerated data types, I get a compile error. I can't do it. So what I really want is this is going to limit what I'm allowed. It's going to be the numbers 0, 1, 2, 3, and that's it. You give me a 4, it doesn't allow me to run it at all. It's also an enumerated data type, so it's a constant, so I can run it with a switch statement. I could say, by the way, the switch is based on this PD, and if this is equal to mouse, I'm going to return mouse, just the text name for it. Case trackpad, return trackpad, case finger, return finger, and let's do default. And I'll check out what the question was. All right, so if I don't pass in anything reasonable at all, I'll use the default, which will be the pen. Okay. 2 questions. If a struct contains numbers and there are variables which represent a number, can the struct be referenced? Example, my val is equal to 3. Yes, you can definitely get the value in the struct directly. So you'd say whatever your struct's name is, dot my val to get the value 3. By number like the order in the struct? No, you cannot go by the order within the struct though. So you can sort of, if you know how this, you're not supposed to essentially. You're supposed to think of them as a collection, a grab bag of different variables wrapped together. Technically, they are put in a particular order. So if you get really fancy with your pointer arithmetic and all this other kind of crazy crap, you can actually manually say, no, go 5 positions into this struct, move move where I'm looking in memory, all the crazy things that you should never do. Yeah, you can manually force your way into the struct at a particular point and get a particular value, but you shouldn't. So you can't go, it does not get by order. Since it's a grab bag of different things, and because you don't know what order things are placed in your struct, if I move things around in my struct at all, what's going to end up happening, I'll get to structs in a second. To remind me if I don't answer your question, but if I rearrange things in my struct and I did that numbering approach, everything's going to break. I don't know how that's actually going to end up working. So character members, or it might be one way. Okay, I'll do a character string with my struct as well. What would I call that? Like struct? Oh, if I make an array of structs, yes, it would be. Let's do an array of points, and we'll do that, and I'll get the second value for it. Okay. So this would be a switch statement. Notice it's all returning a string. So let's close this off and let's actually test this thing out, because I don't trust myself. What is it warning me about? Okay, enumerated pointer type is unscoped. Okay. It prefers enumerated class over enum. Okay, so we can do that if we wanted. And that might barf on us a little bit. Yeah, that's and the old way of doing it, the enum way of doing it. That's how I learned it originally. It's not an enumerated class. Now what I would do is this. And it should be dot or double. There you go. So two different ways I could do it. I could say an enumerated class pointing device, and then that will give me this way. I think that's what I'm doing on the assignment. So let's just throw it in this way. The old way of doing enumerated data types, you could say it's this, but am I sure that that's, if I say the word mouse and I define another new enumerated data type that also uses the word mouse, but I called it, one of them I called it mouse 1, mouse 2, and I screw those up. Because it doesn't force me to say it's a pointing device named mouse, because I'm not forcing that sort of the scope of it, it can lead to errors. That's why it's an enumerated class. It's a slightly different beast, but will still work. I would consider both would be fine. Trackpad, there we go. All right. So I want to actually call this function. What did I call this function? This should have actually, oh. Why is that? It shouldn't be barfing on me about that though. It's a pointing device. It's a pointing device. That's fine. Oh, it got rid of the error now. Okay, good enough for me. Device. Okay, hold on a second. Sorry about this, folks. This is Google blocking me and letting me type in stuff. Device name is equal to, here's my function call. I'm lazy, so I copied and pasted. And I'm going to say PD. That's what my pointing device was named. And then I'm going to have, let's do a printf statement. The device was a /n and then p device name. Okay, this should do it. Oh, I need to include how this is defined. So can I get my, I always want to use IOStream, but it's not the proper thing to use, but I'm going to use IOStream yet again, just because it's easier. Include, and then let's see. I don't want IOStream, do I? IOStream is not the exact right library, but it's the one that comes to mind at least. Okay. Well, I don't think I need the typedef thing anymore. There you go. And I'm looking at my error messages as they come up, just in case. Okay, this is Windows thinking I did something wrong, but okay, the device was a trackpad. It went in here, it looked at the switch statement, figured out which one of these branches it went on. I passed in a trackpad, so when it got there, it just returned the word trackpad, and now my printf statement goes, the device was a, and this thing returned the word trackpad right here, and that's what output to the screen. Okay, I've already made a point data structure. Let's also, I can make a point data structure. I can say what type of device it is. Oh, let's do that too. So here we go, struct, click event, and I'm going to have a, oh, I'm going to need to move that data structure up. Let's move that down actually. All right, click event. I'm going to have a pointing device, and I'm going to have a point P. All right, I can make structs within structs. That's fine. So if I have a click event, it might say, oh, and then let's also do a unsigned int time, the time of the event, let's say. Or I could use a, I think it's a clock event that we used in the lab. But that's for the time being. Let's say it's an unsigned integer for the time, the current timestamp for the computer. So what kind of device did the click, where it was located, and I know it's a clicking device, I know it's a click event, and I know what time it happened. And that allows me to do all sorts of crazy things. So there would be an example of, like, just say a click event. So let's actually play around with this. Let's have an array of these click events. Click event, a events, and I'm going to make size 20, let's say. Great. I have 20 click events. Let's say I'm going to, let's make a for loop with, oh, let's make it size 5. It's going to get really out of hand really fast. Okay. So let's set up a particular, each one of these click events. So let's do something else. Let's make a create event. So click event, create event, and I'm just going to have it, fill in random gibberish. I just want to return a struct that I can store in this array. So I'm going to have it for int I is equal to 0, I is less than 5, and probably I should not use the constant 5. Maybe I should use constant int array size. Num events, let's say. Better name. Everywhere I have a 5, I'm going to put in this. Why? Because if I want to change it, I want to change it in one place. I don't want to have to go through my code finding every single time. I don't know if that's a 5 for the number of events, or if it's some other 5, and maybe it's the number 5 for how many different pointing devices I have. I don't know. I want to have some kind of constant to make sure I can change it fairly easily. All right. And then I'm going to have some kind of way of I is equal to create event. And what we could do, let's, for the time being, let's throw in a variable as well. So int idx, let's say. It's not going to really do anything right now. And so I'm going to put in an I. Great. Okay. EVT for event. All right, I'm going to make an event. I'm going to have EVT. I can get the individual element of this. So the time is equal to 0. EVT dot PD is equal to pointing device, : let's say mouse, a bunch of generic things. And P, that's the point. I should say PT instead for point. So let's change my, there you go, PT for point. Easier to read. And this thing, well, this pointing data structure has an X and a Y. So what I really want is I can go even further. I can go at position X is equal to 0. EVT.PT.Y is equal to 0, let's say, or maybe I'll set it at 100 and 100, let's say. I'm just setting it to safe values for right now. Okay, or I could say 100 times IDX, or let's say 10 times IDX. So it'll be at 0, 0, then it'll be at 10, 10, then it'll be at 20, 20, 30, 30. So I'll be moving the X and Y coordinates. Okay, and then I want to return the EVT. I made this click event. I just return the data structure. This is one of the questions on Piazza, and then it's going to be stored in this thing here. Why not? If I wanted to print off an event, I could just get all those the coordinate information from it. So I can also do this, and I'll look at the question in a second. Num events, I++. Okay, I'm going to do a printf statement. Comma. So let's put those in Cartesian coordinate positions. So X, Y, and then using, okay. Here we go. I'm going to use that particular click event stuff. So A events at position I dot. Then I can figure out what time it is. Then I could figure out a events at position I, and then say, hey, what point am I dealing with? Okay, and then what's the X coordinate for that point? I can go into the point, then into this, then into that. I can nest these as deep as I want. So I have an event, I go into my array. From my array, I then get the event. From my event, I then get the point. From my point, I then get the X value. Right. That's why we have to practice a lot of these things, because they don't always, it takes some practice to get used to the fact that you can have structs within structs, you can have arrays of structs, you can have structs with arrays in them as well, right? You can do all sorts of crazy things. And I'm going to do one more afterwards. And here we go. I want to call this function up here, get device name. I'm going to pass in a device name right here. So in this case, I want the device name, which is E events at position I dot. I need the P pointing device, and that should do it. So I can, if I get the pointing device, I pass it into this function, which then passes out a string. Let's compile it. Let's see what your comments were, and then we'll go from there. Okay. Let's see how we're doing this. Okay. 2 questions. So we didn't talk about the moving things around within the struct and having the order of operations work in the struct, but I'll show you an example of that it won't make any difference. Okay, representing the numbers. One way of doing this. If I make an array of struct, would I call that struct if your name of your array was called struct, then the 1th position, 0, 1, so the second in the array, and then you got the value from it, yes, you would actually do that, right, which we just showed right now. What's the point of using enums in the zodiac assignment? After we do the calculations on the birthday to get the number that corresponds to the zodiac, when we just switch the number to the zodiac sign using this switch statement. So if I have a number, let's say, and you give me the number 44, what zodiac number is that? That's it. If I want to make sure that you do not pass me anything other than a legitimate zodiac number, and quite frankly, you might think I would never do something. Everyone does something. Everyone does something stupid. My code is constant. You may have noticed. Everybody has little screw ups all over the place. And so if you, by using an enumerated data type, it allows you to use a switch. You could have used a number, but if somebody accidentally throws you a -1 into your function, you won't accept it. Versus If you allow it to be any number and you pass in a -1, suddenly you get weird things and it's harder to track down. The enumerated data type just constrains it more. It's essentially saving you from yourself. If you allow yourself to have a whole bunch of different types of data, if you're trying to get all cutesy with your code, if you're trying to do pointers of this and that, if you try and get really creative with your code, you can do it, but eventually your brain is not going to be able to keep up with your code. Everybody hits that point at some point in time. It might be 3 years from now, it might be tomorrow. You don't know, but at some point in time, every programmer I know, at least everyone that got a little cocky and played around with code, myself included, you get to some point where you realize your brain is not able to keep up with the complexity of the code you're generating. And so this is very much just good force of habit. It's like study skills, right? You put yourself into a sort of a forced regiment, which is this thing here is you cannot pass me anything that is not a legitimate zodiac number between 0 and 11 or whatever the number I'm giving. It's also a whole lot better to say rat than 4. If I'm looking at my code, I'm looking at 4s and 5s and 6s, I have no idea what those numbers mean. If I say the year of the rat, I know what that means. That's why we use enumerated data types. Easier for you to read, and you don't screw yourself over. You don't have your code break on you in weird ways. So I don't want to say it is device number 1. I want to say it's a mouse. Instead of saying device number 3, I want to say it's your fingertip, right, when you're touching the screen. Hopefully that answers your question. If it doesn't, please let me know. But no, the exam 2 is a little more than 2 weeks from now. Will there be any coding on the test this time? Yes, there absolutely will be. How would the layout be for the test? Okay. So yeah, and that was a great question, by the way, Maurice. So Nick, there definitely will be coding on the exam because that's what we're testing for. Before, we didn't have enough code to really do it. Now, it's not only coding. I may have multiple choice questions. I may have a matching question. I may have a fix the bugs questions. I love those questions. You will not see me say define a struct or what is this struct that we learned in the assignment? I won't ask that kind of question. I won't ask memorization questions. I'll ask you to solve a problem. So if there's a bug in the code or if there's something wrong with the code, you identifying that is something that shows you understand the concepts. If I ask you to write, let's say, the get device name function that I just said made here, that would be tested. That you've never seen this pointing device thing before. I'm not going to be testing enumerated data types necessarily, but if I give you a struct and say use this struct, that would be perfectly reasonable. And normally, if you do something like that, I can't stop you from using Visual Studio, unlike for a live exam in class. And so one of my big things is like, yeah, if you want to use Visual Studio, fine. Don't let it get in the way, however. So some people, I'm always afraid that some people will freak out if their code doesn't compile and they won't submit their work. And I'm saying, no, submit whatever you have, even if it doesn't compile, because compilation is not the requirement for the exam. Unlike an assignment, I don't care if it should compile, hopefully, but I don't want that to hold you up. You can be like 99.9% of the way there, get 100% in the grade, you're missing a semicolon. I don't want that to hold you up. So the format, I don't know what does, Nick, maybe you can help me out with this one. Sorry, but to put you on the spot here, but what do you hope to get from the format of the exam? And I understand there's some things like, are there multiple choices? Are there long answer questions? I'm not going to give you 100 multiple choice questions, for example, like my psych exams used to be when I was a student. But at the same time, I can't give you the actual questions, right? So it's mix of different kinds of formats, trying to make sure you can definitely be done in an hour and a half. I'm asking for, I can't ask for memorization questions. I tend to like asking questions that if you took the class, you have an easier time. That way, if you send your code off to some external site, like some students do, which you shouldn't do, anyone that does that, it suddenly screws them over a bit more because it's harder for the other person to know what you're trying to get to. For example, you can't use CN and cout statements. If you send it off to one of these external sites, they're going to give you CN and cout statements 99% of the time. And your code is wrong. Hey, right. Just so there's no surprise. I don't want to go to the test and boom, surprise. Yeah, I have a problem with that too. That would be an impressive exam if it was code to write fire a rocket, but no, I can't give you anything like that. It has to be something that is easier than the assignments, but not so easy that you just sort of walk in off the street and pass it fine. If you're doing the work throughout, my line is always, if you're doing the work throughout the term and understanding it, and you're not getting help from friends, your friends are not giving you answers or anything like that, the exam should be fairly easy. I never can guarantee that because I always think some of my exam questions are easy and then I find out they're brutal. It's very hard to gauge. But my normal line is, if you're doing the work, you're doing the labs, and you're doing the assignments, there should be no surprises or anything that really hurts you on the actual exam. All right. So let's get back to this one more time. I wanted to look at one more chat question. Okay, perfect. No problem. So let's actually here's what our point thing is. Let's just get to one earlier comment. What happens if I did this? I have now reversed X and Y in the struct. Technically, should that make any difference? No, it shouldn't. I have an X, I have a Y. Nothing has changed. The struct definition, how things are structured in the data when I make when I make one of these point structs, where it's located in the data has completely shifted around. One's on top of the other now. But it shouldn't make any difference to any of my code. That's the point. You can think of a struct as a set of different variables, not a list of variables. Their order should not matter where they're ordered, and that's why you cannot access a particular parameter by a number, because you don't know the order. It could be the X comes first, or it could be the Y comes first, or it could be some string comes first. You don't know the order, and therefore you cannot work under the assumption that there is a particular ordering. That's why it's dangerous to try and do these little tricks to access individual elements. You want to just jump directly to the element. So I have a point P, I go P dot X or P dot Y. My code should still work. All right, let's run this thing and see what happens. I may have something wrong here. I have trackpad, a click event, add 0. Oh, I didn't put a new line each time. So let's fix that so we can see the output better. /n. All right. All right, let's have a, okay. So this is what we expected, right? This create event thing was garbage. All it did was set all the events to almost exactly the same thing, except it was slightly different. So what I could do, so here we go. I have a click event at time 0 because I didn't set the time at 0, 0 using a mouse, and they're all using a mouse essentially, but at position 10 and 100, 20 and 200, 30 and 300, 40 and 400. I think I actually did the math wrong in that create event, but I used a for loop to create a whole bunch of these events and put it in an array. And then I used a for loop to call a print statement, and I got the individual part of my struct using the structure of my struct. It's almost like it's right in the name. It has structure. So the idea is that the struct gives you some kind of ordering, or it allows you to encapsulate a whole bunch of data that you need all at once, like an event, like a mouse event. That's literally what mouse events are. If you're doing Windows programming, if you're drawing a graphic user interface, you get a Windows event. You'll get a mouse event with all the data you need in one structure, and it gets sent around. You're not passing in the X coordinate, the Y coordinate, like 27 different parameters. No, you get one data structure that goes into your function. That can also be returned from your function. So I missed this what we missed. Let's make it 20 times. What the heck, right? It's going to be different. I'm also going to do something else. I'm going to, instead of this, I'm going to do, can I do this? Let's see. This might barf on me. Let's see if it barfs on me. Okay, so if I'm casting it to a particular kind of pointing device, let's find out what happens. This is saying you're taking some index 0, 1, 2, 3, 4, 5, up to, but not including 5. The number of items I have is 0, 1, 2, 3. So I have one extra device in there. Let's see what happens if I do this. It might blow up in my face. Pen and pen. Oh, it's because of default. Okay. I thought it would actually give a compiler for trying to call a function that it is not. Oh, I know what the problem is, but okay. So 0, 1, 2, 3, 4, 5, 6, 7, they'll all be pen. If I did 20 elements, every other event afterwards would be pen. I could figure out how many elements I actually have in this data structure and then go from there. But effectively, notice I can use the index to change things around for me. I have an enumerated data type that I really don't care. I can say it's an index, and then I just say, no, it's a pointing device. It's just a number, and pass that in. I want to try something else here. Let's try 17. Yep, there you go. An example of why we use enumerated data types. If my number is wrong, if it's an integer, and I pass it in, it yells at me. If I say it's a pointing device, it'll accept almost anything. But if I just try and pass in a number, and that number is not an acceptable number, it's not in the proper range, it gives me an error if you hadn't noticed. It might give me an error for everything though, so for all I know. So maybe it's going to give me an error for everything. I'll have to cast it each time. But again, you can cast it, or you can figure out what makes it work. So yeah, maybe that's not as useful as I thought. It would give me more of an error than that. It's one of those things you figure out. I know why an enumerated data type is there, because when I don't use one, I found out the hard way that it's problematic, right? If I have a number and I'm trying to match it up each time, if I accidentally forget a number, if I missed a particular number, if I want to make sure I hit all the particular devices, it comes in really handy for when I have a contiguous set of numbers, like the Chinese zodiacs, right? It goes from one number to another, and then it'll loop around. Okay, did I have a question? Let's see if I have a question here. Okay, so hopefully that's going to be useful. Let's try one other thing. Let's do, let's see if we can do some math, because I know you guys love your math. I'm sure of it. So math.h, okay. I'm going to do some math here. So let's figure out what we can do here. I'm going to have, it's going to be a double vector distance. Yeah, that should do it. And I'll have P1 point P2. This actually was an exam question, a midterm exam question, but I also gave a whole lot of hints along the way. How do you figure out the vector distance of two things? Well, that's Pythagorean theorem, right? I have a point here, I have a point here. I figure out this is the hypotenuse, right? So I have x squared, the difference in x squared, difference in y squared, add them together, square root of that. It's the hypotenuse of a triangle, right? So that's how you'd actually figure out the vector distance between 2 points. I have 2 points in space. I can figure out how far that distance is by using a right angle triangle. Okay, so what I want to do is I want something that says the x difference. Okay, minus p2 dot x. All right. And then afterwards, what do I want to do? I want to square both of those, and then I'll take the square, add them, and then take the square root. Well, I don't even need the square function. I can say x diff times x diff, that's the square, easier than calling a power function, plus y diff times y diff, fine. And then I will take the square root, should be that, of those numbers. look at that distance, return distance. All right. So structures are really useful for that sort of thing, right? I'm not passing in four numbers now. I'm passing in 2 points. That's it. Point 1, point 2, done. The old way of doing it before you had this was I had to figure out what the vector distance between, I need to pass in 4 different parameters to get this. I could also figure out, let me think of a good example of this. If I wanted to figure out, the minimum point. Okay, so before, when I was trying to find the minimum x and the minimum y, I'm trying to find the minimum point between in these two values. So if I have a rectangle, let's say, there we go. If I have a rectangle, let's say, I'm trying to find the minimum point in that rectangle. Well, the old way of doing it was I had to pass in just the x coordinates, figure out the minimum of those, pass in just the y coordinates, figure out the minimum of those, and then make a point or somehow deal with those 2 independent numbers. What I really want is just give me the minimum point. Don't monkey around. I don't want to have to know how all this other stuff works. So minimum point function. We'll try both these functions in a second just to make sure that they work. So why not? Okay, so here's my minimum point function. What do I need to do? I need to figure out what the minimum of x position for P1 and P2 are, and the minimum y position between those 2 points. So let's see here. Point, I call it retval, return value, just because me. Okay, I'm going to just set retval to be equal to 0.1. Hear me out for right now. I'm going to assume 0.1 is the minimum x coordinate and the minimum y coordinate. It may not be. If it is, I don't change anything. I just set it to that and I'm done. Then what I can do is I can check to see if it is the minimum x coordinate, and if it's not, change it. And then I can check to see if it's the minimum y coordinate and then change it if I need to. So 2 if statements versus an if else a bunch of times. If that makes sense. Hopefully it does. If, and I want to see if p1.x is greater than p2.x, then I want to say retval.x is equal to p2.x. I'm looking for the minimum, right? I have another if statement. If p1.y is greater than p2.y, retval, typing would be useful, .y is equal to p2.y, right? If it's not the minimum x, change it. If it's not the minimum y, change it. Return retval. And I can pass back 2 variables at once. That's the other reason we like structures. I don't have to have set. Before, I only had the ability to send back 1 value with my return value. If I have a struct, I can send a whole bunch of variables all at once. It's one of our workarounds, ways to return multiple pieces of data at one go. And I can send multiple pieces of data into a function in one go. It also organizes my data as well. So let's call these functions in a second. Let's give some tests. What kind of tests could I do here? Actually, let's see if you guys, just to wake you guys up, what would be a good test? So I want to test, was it vector distance, point distance? What the heck did I call it? Vector distance and min point. So what would be a good set of test cases? I'll wait, and so let's see what kind of things we could pass in here for my test cases. What would be a reasonable vector distance for, if I'm trying to get the vector distance, I would say double, and then I may have some kind of assert, let's say, that distance test 1 is equal to, and the asserts are not normally what we do here. This is just me being a cheapskate here. The real thing to do would be having some kind of formalized unit tests for testing your code. But I want you thinking about what your code should be doing, right? So if I pass in, what kind of variables could I pass in here to make this, to test things out? I'll wait for a response from you guys. And honestly, I'll wait for a response. And then besides that, then we'll also do point min point is equal to, and then this will be min pt. And I'm going to pass in 2 structures in here. These structures are just going to be my points. Or if you have a question and you want me to clarify something, I'm more than happy to, because I might be going too fast. That's why I want to get your feedback, because if I'm wrong and I'm really going too fast, I need to slow down. If it's clear what the kind of tests you can do, we'll find out that way too. So please put in the chat what kind of tests could you test for. You don't need to formally write it out, just give me some points and what you'd expect, or even approximately what you'd expect. Still no response yet. Just warning myself in advance. Because I have to pick up my kids in about 8 minutes or so. I can be a tiny bit late, but I'm not going to wait around if you guys are not going to give me any kind of answer. So I'll wait. And that's me being a jerk, I know, but at the same time, I do expect you guys to be thinking through things. If I'm trying to test 2 vectors, I just have points. What would be, give me some points. So here would be some points. Oh, there we go. About time. There you go. Thank you. 0, 0, 3, 6, and 6.7. Now, 6.7, I'm not sure it's going to hit exactly that mark. Is reasonable to look at. Okay, so let's try this. 0, 0. That's 1 point. Notice I could make a point struct, or I could just define it directly in those curly braces. And 3, 6. You're claiming, and I think you're probably right, and because I can't do the math in my head at least, that this is about 6.7. We're going to see it blow up in our face, and for one reason and one reason only, and that's, oh, I need to include asserts. Okay. All right. Let's go back down to what we had here. The only reason this potentially could blow up in our face is because doubles the precision. We lose a lot of precision when we're doing this kind of math. It might be, 6.666666669, right? And it rounds up to 6.7, but the math just doesn't quite work. Anything with an irrational number is going to blow up in our face, or it's not going to be exactly right, but we're going to find out. And then give me another number, if you could, for the minimum point. Great. Let's see. What do we got? You mean vector distance, like printf is a built-in function? I don't think, no, vector distance is not a built-in function. It's up here. Right here. That's what I was defining earlier. So yeah, maybe I'm getting ahead of myself. It's 2 points. I'm telling the distance between 2 points in space. It happens to be the vector distance if you know linear algebra. Sorry if the word vector is spooking you, because I know it spooks me every time. Just saying it right now just spooked me. It's not a built-in function. I wrote this function myself. It takes in my data structure called point 1, my data structure called point 2. That's why I wanted to get you guys your feedback. Great. And it will say what the distance between those 2 points is. Not the Manhattan distance, not this, but the angle distance. All right. Oh, let's do another one of those. 1, 1, 8, 2, and 7. Okay. If it gives me a solid number, it's going to give me a better, it's going to be correct. 1, 1. All right. And then also I need that minimum point. Was it 8, 2, and 7? No, damn. 8, 2, and 7. Okay. And that should be distance 2, and that's going to be 7. If it gives me a solid number, it's not going to give me 0.000001. Let's hope. What other things could I have tested? I won't belabor the point too much. What I want to test? I want to test like the same number. So let's do one more. Oh, I don't want to do it there. I want to do it line below. I'll make it distance 3, 1, 1, and then 2, 1, 1. What is the distance there? Well, it should be 0, right? That is a sort of consistent thing. It's the kind of edge case that I sort of want to look for. All right. And do we have one for our minimum distance? Okay. So a function can be called in one line from the given input. Yeah. That's me calling the function, and I didn't need to make a structure because this is me generating a point structure right here. That's what that's doing based on our definition. If we made a separate point structure, we could pass it in. That's fine. So this is me making a point structure right there. It's asking for a point structure. I give it something that looks exactly like a point structure, and it goes, okay, and goes from there. I normally don't do this. Normally, I would make a point structure and pass the point structure, make a point structure, because debugging can be a pain otherwise. Okay, and I'm going to run this, but come to think about what you want for the minimum point. Oh, we have a problem here. What do we have? Minimum point is the problem because I didn't put anything in there yet. So what kind of minimum point could I have? I'm going to take one of the easy ones for us. Haha, right? The minimum point should return a point. What is wrong with this thing? Let's find out. Click event vector distance min point. It returns a point. Takes in 2 points, right? So what is wrong with this thing here? It returns a point that's been being, oh, it's because it's the name of the function as well. There we go. Name of the function. It didn't let me do that. Okay. Okay, let's have a look at what we get here. I think it's going to blow up in our face, but let's find out. Hey, it blew up in our face. Great. I know that you don't think it's great, but there's nothing wrong with this. This is just saying something weird happened. Something weird happened because, remember, a floating point or an irrational number does not give me 6.7. It gives me 6.700000002. So what we need is something like the distance between the value returned and 6.7 is less than 0.0001 or something like that. You need some way of creatively testing to make sure it's in a reasonable range. For the time being, let's just comment out that assert because the other ones should work just fine. But anytime I'm testing to see if it's exactly 0 and I have a rational number, you want to test to see if it's close enough to 0. These are the little bugs that'll ruin your evening. So, oh, we have another one. Where is it? Oh, what's this? 7.007. Oh, it doesn't give us something exact unless I'm doing something wrong. 8 minus 1 gives me 7. Squared is 49. 2 minus 1 is 1. Squared is equal to 1. That's 50. Yeah, it's not going to give us an exact rational number because it's not going to be. What could give you an exact rational number? If I had an 8 and an 8, I double them together, I'll get 16. Square root of that will give me 4. That would work, but this is not going to give me exactly, at least I don't think it will. Maybe you guys are better at math than me. Difference between a struct and a class. That's where things get really weird. So the question to clarify for everyone here is the difference between a struct and a class, and they get really close to one another. We are only touching classes only exist in C++. Structs exist in C. Structs allow you to do a lot of other things, especially if you use C++ version of structs. But a struct is originally just meant to be an encapsulation of variables, no functions. A class is wrapping up both the variables and the functions associated with those variables together in one unit. So instead of a C string like we were doing, what we're going to do, or instead of this point structure that we made, what if I also included with it the ability to calculate the distance between 2 points? What if I encapsulated into it the magnitude of that point? What if I included a whole bunch of other functions that have nothing to do, like that are the functions associated with points? If I wrap them all up together, that's a class. And we'll be doing that in BIT1400. We can't do that here. That's purely C++, but that's really the difference, one of the big differences. Now, structs also allow you to write, because, why not? And it's C and C++, they get all kind of crazy on you. Structs are originally meant to be just an encapsulation of all your data structure wrapped together. And now you can make functions that are wrapped in your struct, and then it's all weird. Yeah. And they get really close to one another now. But the original premise of a struct is build your own data structure. That's all it is. It's not was not originally supposed to have its own functions and stuff like that. And now it has ability to have member functions. So the big takeaway is a struct is just the data. It doesn't have any functions. When we get to classes, it does, but we'll pretend it doesn't. When we get to classes, it's data and the functions associated with that data wrapped together. So if I have a string class, it has both the string, the variables themselves, and it has functions that you can do with a string, like concatenating strings, like removing the letter R from the string, like getting the length of the string, like appending thing, like appending. That's concatenation. Like let me see here, clearing the string, right? It has a whole bunch of functions wrapped up with it, and that's the difference between the two. But they are both blueprints. Okay, so this is going to be a problem. Okay, but we figured these things out. This one won't give us a problem per se, hopefully. And I think, what would it be? 2, giving me 4. So if I have the difference of 2, I know 2 squared won't do it either. Oy, I'm not even sure how, there's not that many cases where you're going to get a vector that's going to give you an exact non-rational number. So it's actually really hard unless you're giving the exact number, same number. But I liked going over that fact with you guys. Okay. Hey, maybe I screwed up this one too. Oh, that's why. I suck. Okay. 3. There you go. The curse of copying and pasting. It gets me every time. Okay. There we go. So I did all that kind of stuff. We have a bunch of assert functions to make sure things work, right? What would I expect here? I would expect 7 or approximately 7. So you can have some way of testing approximately 7, right? You could say the distance test to minus 7 is less than, and an absolute value of that is less than 0.00004, something like that. That would be a great test. Wonderful, right? You're just trying to throw things at your function, see what it spits out, and make sure it's working correctly. Because if I pass in something different, or if I'm not testing this, how do I know it works? Printf statements are not going to do it for you. Getting the user to type in something is not going to do it for you. I want just a battery of tests that I can just be certain I've tested all the weird edge cases. So I have a weird edge case. I want other edge cases. So what other kind of cases do I have? Can someone give me an example of, and we'll stop in a second. Can someone give me other examples here? So let's try 0, 0, and 5, 5. I would expect 0, 0, right? What other thing do I have? Well, I could do 5, 5. I would expect 0, 0 as well. I would also expect to have, let's say 5, 5, and I get 0, 0 as well. So I could expect assert min point val is equal to, I can actually do a direct equality here. It just means every single bit is identical between these two things. That should have done it for me. Oh, I need to make a point. Okay, can I do a comparison between the two? Okay, that'll work for us at least. Min point val 2, 3, 2, 3. All right, just see how these things work. And one more. 4, 4. All right, I'm expecting this is what I would expect. I could have just said 0 and 0. I thought I could just do a straight comparison, and nothing blew up. It always gave me 0, 0, even when the thing I was testing on was like 5, 0, 0, 5. It's finding the minimum of 5 and 0. It's finding the minimum of 0 and 5. What I could do is also check to make sure it doesn't give me 0, 0, 5. I put -5 and -5 in there. Right? I'm trying to figure out all the weird cases, all the weird events that might come up. So something like that's not going to give me the same answer. That's going to give me 0, -5, -5 as the point. And I want to check to see if that's in fact the case. Right? So I can do this. This is, I'll make 5, then I'll stop. Honest. I've been saying I'll stop for the past 10 minutes, but honest. All right, run it, see what we got. All right, and if I run this code, I would expect it to pass all the way through, right? You're not seeing a wall of text. You're not seeing a bunch of other things. A good test, just make sure you've kicked the tires, right? You want to test it before you test the plane before you take off on the plane, right? This is just a bunch of testing. And it's just a good habit to think about how your code can break down. It won't be perfect. That's fine. I want you to think about where the weird edge cases are, where things could blow up for you. That's what we're asking for when it comes to testing. Okay, I'm hoping all this struct stuff is making sense. Let me stop sharing my screen. And let's see if we have any other additional questions. Otherwise, I'm going to stop there. All right. Does anybody have any additional questions? This is a relatively small group of people here. Next time around, we'll actually be looking at input and output and strings. And then after that, we'll look at dynamic memory and pointers. So things are going to get, they're going to seem a little crazy, but it shouldn't be that hard. If you got structs, it's hopefully fairly good now. That's perfect. I'm glad to hear it. All right. Thank you very much, everyone. And good luck on passing the assignment. You guys are doing fine. Thanks.